So since we have no further equation for the tutorial 6 for the double integral, then we'll start the tutorial 7. Question 1. Compute the multiple integrals. Okay, so this is a direct question where, of course, you just test your technique of integration. Because all the limits are given there, you just direct integrate. So this question 1, 2 are applicable. 1 is direct question. Question 2 is conversion scale question from Cartesian to cylindrical coordinate. So we look at question 1 first. Okay, so compute the multiple integrals. Okay, the triple integral we have xy dx dy dz, where the limit of x from 0 to y, limit of y from 0 to square root 4 minus z squared. Okay, lastly, limit of z is from 0 to 1. So this one you just directly integrate it. So you start integrate this one, integrate respect to x first. Normally we integrate respect to x, we assume that solid G is actually parallel with x-axis. Okay. So the outer two integral there, 0 to 1, 0 to square root 4 minus z squared. When you integrate respect to x, y and z are constant. So you integrate, so you have the x squared over 2, y constant. So factor out y, you have dy dz. Okay, limit for the x is from 0 to 1. So half k is a constant, and factor out, so you have half, then 0, 1. Limit 0 to square root 4 minus z squared. So you plug in the upper limit, you have y squared. You plug in lower limit minus 0, so you can skip there. By y dy dz. You plug in, factor out half, so you have y squared. Then after you still have y, because you plug in 0, you have minus 0 there. Okay, so now you have y squared times y is y cubed. Integrate y cubed respect to y. So in this case now we have actually half 0 to 1 to 0 to square root 4 minus z squared. Total is y cubed dy dz. So integrate y cubed respect to y, we have actually y power 4 divided by 4, 0 to 4 minus z squared dz. dz. Half k, this one divide by 4, total is 1 over 8, k, factor out. Then plug in here. So you have square root 4 minus z squared power 4 dz. You may simplify it, and lastly, either you integrate manually or you can use your scientific calculator to integrate it. So we simplify first. Okay, square root is actually power half. So power half times 4 is actually a power 2. It's 4 minus z squared power 2 dz. Either you use scientific calculator or you may expand it and then you integrate it manually. 16 minus 8z squared plus z power 4 dz. Or from this step, you may use your scientific calculator to integrate it. So last 16z minus 8z cubed over 3 plus z power 5 over 5, 0 to 1. So plug in the upper limit at 16 minus 8 over 3 plus 1 over 5. So please evaluate it and check whether you get same with the answer given. And 203 divided by 120. So this is a direct question where you just need to, because you no need to sketch the graph, no need to think of the limit, you just need to concentrate on your integrations. So any question for question 1 here, tutorial 7, question 1. Hope you can do well in your test. This coming test 1 is on this Saturday 8 p.m. And please enroll to your author. I think you can see the test 1 that EFC is another. Okay, I think you already enrolled. So please check to the SEM 2 test 1 BFC 24103 Mathematics 3 in your author classroom for your test 1 there. Okay, and then for your exam, please install your for example the cam scanner. So you may if you got tablet, you can just write as what I did here. If not, you write on pencil. Please scan directly using cam scanner and save as PDF. Save as PDF. Don't save as picture, then convert to PDF. Then you will take a larger file size, and the image is not that is not enhanced compared to use cam scanner. You can directly enhance your writing there, your image to a better quality. Okay, so this is question 1. Question 2. Okay, is yesterday the Cartesian to cylindrical coordinate yesterday. The last day, not the last example, because due to time constraint yesterday, we did discuss one of the example, which is conversion from Cartesian coordinate to cylindrical coordinate. How to convert? C is CD. To do conversion type of equation, first of all, you have to look at the limits. This is dz, dx, dy. So this is a limit for z. So mean lower limit up to upper limit. So mean z actually is from x squared plus y squared up to third x squared plus y squared. So you must understand what this. This one is actually tell you z equal x squared plus y squared. This one means this is a lower surface. This one tell you this is a lower surface. This is actually z equal third x squared plus y squared. So tell you upper surface. And then you must familiar with all these popular 3D graph. Z equal x squared plus y squared is actually paraboloid. Paraboloid which open up minimum point x0, y0, z0. So this is actually mean the z equal x squared plus y squared is actually paraboloid. This one, z equal x squared plus y squared. Convert the cylindrical, this will be equal to r squared, and actually this is a paraboloid. Consists of the parabola. Okay, and the upper surface z equal square root x squared plus y squared. This one is actually upper cone. Upper cone. Okay, straight line. This is the upper cone. Okay, you want to convert to using cylindrical, then x squared plus y squared is r squared, so this is equal to third r. Third r. So using cylindrical coordinate, actually we maintain the z. So there's a limit of z, okay? X squared plus y squared, you change it to r squared. Third x squared plus y squared, this is become r. Z maintain, dx dy change it become dx dy, will become r dr d theta. Okay, this one become r squared. Okay, this one change it to r. Okay, and you have x actually x change to r cos theta, y change to r sin theta. So from limit of z, okay, we convert to in terms of r already. Now we need the limit of r and limit of theta. Okay, and the limit for x and y will tell you, okay, what is the limit of the r and limit of the theta. Okay, from limit of x, this one is actually x equals 0. Okay, this is actually x, x up to square root 1 minus y squared. Then from limit of x, for the limit of x tell you 0 less than x, it less than 1 minus y squared. So mean x equal to 0. Okay, this one is actually the left curve. Left curve. Okay, upper limit will tell you the right curve, which is x equal square root 1 minus y squared. So again, you need to familiar with the graph. Okay, x equals 0. Okay, exactly, this is y-axis. This is the x-axis. So x equals 0 is on your x equals 0 until x equal, you still have a until x equal positive square root 1 minus y squared. This is 1, this is negative 1, this is 1. It's actually, when you square back, this one you have x squared plus y squared equal to 1. So mean a unit circle, if you cut it vertically at your y-axis, then this is actually the right hand side of the unit circle, which is given by x equal to square root 1 minus y squared, because right hand side x is positive. If x equal negative, sec 1 minus y squared means this is a left hand side of the unit circle. Okay, from limit of x actually tell you, okay, your projection of the r, okay, projection of r is actually you have a right hand side of the circle. Okay, and later on, okay, from the limit of y tell you y from negative 1 to positive 1. Okay, so limit of y negative 1 to positive 1, so means, okay, you have actually the full right hand side circle. Okay, and this one is actually x squared plus y squared equal to 1, so r equal to 1. That's why limit of r is from, because r is from the origin up to the radius of the unit circle. That's why r is from 0 up to 1. Okay, and you have the right hand side circle only. That's why your theta is actually, okay, when you look at it here, this is from 3 pi over 2. 3 pi over 2 up to 2 pi is here. So we can use another one, another version. If I rotate from bottom, this is negative pi over 2 until positive pi over 2. Negative pi over 2 until positive pi over 2. Okay, because okay, theta, if we measure, okay, like this, anti-clockwise, this is theta equal to 0. Okay, up to here, theta equal to pi over 2. Up to okay, this one, theta equal to pi. This is theta equal to 3 pi over 2. So once, okay, full cycle, theta up to 2 pi. Now we involve the first and the last, the fourth quadrant. Okay, we have another way. If we okay, if the theta is measured, okay, if the theta is measured here, clockwise, so up to here, this is actually theta equal to negative pi over 2. If the theta is measured, okay, clockwise, so that's why 3 pi over 2, okay, can be equal to negative pi over 2. So that's why the theta is actually from negative pi over 2 until positive pi over 2. Because from here to here. From it to the first quadrant. So theta is from negative pi over 2 to positive pi over 2. And this one, okay, actually is combination of the limit of z is actually you have bottom is paraboloid, upper is the cone. Then you combine. So actually, when the solid is here, bottom is paraboloid. Bottom is paraboloid. Z equal r squared. Okay, upper is actually z equal r. It is actually the solid is actually bounded bottom by paraboloid, top is by the cone, and your okay paraboloid and the cone intercept at z to be z equal to 1. Z equal to 1. When you solve these two together, we get here the dx dy, the projection is unit circle x squared plus y squared equal to 1. So this one, the intercept at z equal to 1. So when you project it here, so this is a projection, is on your xy plane, which is a unit circle. Okay, but this is from limit of z tell you the surface, the solid is bounded by cone, okay, top surface is cone, bottom is a paraboloid. Okay, however, you need to look at the limit of the x. Limit of x tell you, okay, this is your circle is right hand side circle, and then limit of y against confirms that y from -1 to +1. So -1 to +1. That's why your theta is from -π/2 to +π/2. If limit of y, if the questions limit of y, lower limit change to 0 up to 1, so means the region is on first quadrant only. Then the theta will become 0 to π/2. So before I proceed, do you have any question here how to determine how to determine the r, the theta, okay, and how to convert here. Okay, Cartesian to cylindrical, z maintain, dx dy change to r dr d theta, x squared plus y squared change to r squared. So this one, square root x squared plus y squared, it become r, x change to r cos theta, y change to r sin theta. So you already convert the inner integral, which integrate respect to z. So r dr d theta, you need to know the limit of r. So from the limit of x and limit of y, you know that your circle is at the fourth and the first quadrant. So theta from -π/2 to +π/2, and then the r, okay, from the upper limit of your x, when you square, actually you get x squared plus y squared equal to 1. That's why r is actually 1 unit. So do you have any question? Because the conversion question will be a little bit higher level. Which limit? Which one? The z of the y. Oh. This one, x squared plus y squared equal to r squared. This is a Pythagoras theorem. Not Pythagoras theorem. This is a x squared plus y squared. How to change to r squared? Is it?
So yang sebelah itu kali hujung jadi -π/2 to π/2, right?
Yeah, because okay. Cartesian to cylindrical coordinate. This involve 3D. So this is called cylindrical coordinate. Cylindrical coordinate. Going back to the notes here for you. R you change to x you change to r cos theta, y change to r sin theta, and then x squared plus y squared is actually the r squared. Okay, and then what else? dA is actually r dr d theta. Theta because you have the fourth and the first quadrant. Because it's normally okay, first of all, you see this is a cylindrical coordinate, r theta z maintain, x change to r cos theta, y change to r sin theta, z maintain. dv, okay, we maintain the z because this is normally maintain z is a solid is parallel respect to z axis. Z maintain. Okay, your dx dy or dA is changed to r dr d theta. So z, this one is a lower surface up to upper surface. Okay, r. Okay, r actually from your region r just now we obtain is this one. Limit of x tell you x equal to 0, y axis, until x equal square root 1 minus y squared is the black color curve. The black color curve is actually half of your circle. You cut it at y-axis, you get this one, right curve. Right curve here is actually, the black color right curve is x equals square root 1 minus y squared. And from the limit of y, you see the limit of y here. dy, limit of y, okay, tell you y equal to negative 1 until positive 1. So it's confirmed you have these two, okay, quadrant 4 and quadrant 1. I said, okay, if the equations change a little bit, this one to 0, okay, if limit of y I change it to 0, then you only involve here. Then your theta 0 up to theta pi over 2, up to theta equal to pi over 2. But here, limit of y from negative 1 to 1, so it's confirmed, okay, involve the fourth quadrant and the third quadrant. Okay, we said at this one, this is 3 pi over 2. But how to put limit 3 pi over 2 to pi over 2? I don't know, you can try, but normally we'll put negative pi over 2 to positive pi over 2. If your theta involve these two quadrants, we'll say theta 0. If the area involve first two quadrants, the first and the second, we'll say theta from 0 up to pi. 0 up to pi. The full circle, we'll say, okay, 0 to 2 pi. Okay, it's seldom you have 1, 2, 3 like this because of symmetrics there. It's either first 1 and 2, or 1, 2, 3, 4, or the fourth and the first and fourth. So the first and fourth, cannot say 3 pi over 2 to pi over 2. Because it's not continuous. No? From bigger here, 3 pi over 2 to pi over 2. This one bigger value, this one smaller value. You put it, okay, you can try later on, you try to put whether you can get the answer. We'll say, okay, from fourth quadrant to first quadrant, the angle is from negative pi over 2 to positive pi over 2. Because, okay, here, theta, okay, if the theta measures, okay, positive, is actually anti-clockwise. Okay, if we measure, okay, from negative pi over 2, mean negative is actually your theta is measured, okay, clockwise. So mean, okay, up to here, we have put, okay, mean, okay, fourth and the first quadrant, you put the angle negative pi over 2 to positive pi over 2. And the r is actually from here, x squared plus y squared equal to 1. Okay, so is it okay? Actually, yesterday notes, okay, at the notes, okay, there you have, okay, all that one. Yesterday, I think we finished up to this one, this example. Okay, limit of y negative sub 9 minus x squared. 9 minus x squared is actually, yesterday I said, this blue color. Because, okay, when you square it back, this one, when you square it back, is actually you have y, y, and here you have positive minus square root 9 minus x squared. When you square back, it's actually x squared plus y squared equal to 9. So we'll tell you r is actually equal to 3. So to confirm the theta, you will look at whether your circle is a full circle or semicircle or circle at the fourth and the third quadrant. Okay, and here, from limit of y here, tell you this one. This is 3, this is negative 3. Okay, this lower curve is actually given by y equal negative sub 9 minus x squared. Okay, if the positive sub, okay, positive sub 9 minus x squared is actually upper. I think the graph in the first chapter in the PowerPoint we already gave you. If positive y equal to 9, if y equal to positive third 9 minus x squared is actually upper circle. Upper circle. This is the bottom circle. And you see just now this one, y is the right circle because x equal positive square root 1 minus y squared. It's actually from the circle equation. If we make x as a title, we are positive, negative. When x positive, so this is the right hand side of the cycle. When x is negative, it's the left hand side of the circle. And when you make y as a title, if y positive will be upper semicircle. Okay, if y negative is a up, means it's a lower semicircle. Okay, and then from here, limit of x tell you from negative 3 means the lower curve, black, until upper curve. Okay, limit of y from negative 3 up to 3. So it tell you is actually the full circle. That's why theta is actually 0 to 2 pi. Okay, and then the next one, this one. The same thing, this example. The same thing. Here, y 0 until positive 9 minus x squared. So mean limit of y is here. Tell you have the upper semicircle. Y equal to third 9 minus x squared. This is the y. This is the x. X from 0 to 3. So mean x from 0 to 3. So it's only the first quadrant. Okay, that's why theta is from your theta is 0 until pi over 2. Okay, and here when you square back this one, exactly you get what? X squared plus y squared equal to 9. So it tell you your r is actually 3. So r from 0 until 3. So this is it's important. You must know from limit of y you must be able to sketch the graph, then limit of x to confirm which is the correct region. And then this example 11, example 10 is similar, this part is similar. We look at the dy, you see the dy limit of y from 0 to third 9 minus x squared. So mean your limit of y0 is on your x-axis until y equal here. This is y equal third 9 minus x squared. Okay. This is y. And then x from negative 3 until positive 3. So it's actually semicircle, upper semicircle. That's why your theta is from 0 until pi. So example 10, you see when we just change a little bit of limit of y and x, your theta will be changed. Look a couple of times. Limit of y, the black is y equal negative square root 9 minus x squared. Until the red color, which is y equal to positive third 9 minus x squared. X from negative 3 to positive 3. So this is full circle. Theta will be from 0 to 2 pi. Okay, I change this one to 0, this one to 0. Okay, if I just change a bit only, y equal to 0. So it's from x-axis until y equal to third 9 minus x squared. 9 minus x squared here. So you get is a upper semicircle curve and x from negative 3 to positive 3. So it's confirmed you have first quadrant and second quadrant, which is you have upper semicircle and your theta from 0 to pi. Later on, the 11, 11. Okay. Y same. Y from 0, which is on x-axis, until y equal to sub 9 minus x squared. So it's an upper semicircle curve. And x from 0 to 3. So now it's confirmed it's only first quadrant. That's why your theta is actually from, you rotate here. This is theta 0 until y-axis, theta equal to pi over 2. Okay, this is example 11. And then you see, if I put dx first, exactly, we just look at the dx dy. Because dx dy will tell you the region R there. Okay, x from 0 until sub 9 minus y squared. So exactly here. You have two quadrant. Because x0 is on the y-axis. Okay, the right curve, this one is actually, it's like your tutorial question. Okay, the right curve here is actually x equal square root 9 minus y squared. Here. Okay. x0 until x equal 9 minus y squared. Okay, x0 is here. Okay. And then this one is x equal sub 9 minus y squared. So this is 3, this is negative 3, this is positive 3. It's the right hand side of your circle, right hand side, right hand semicircle. And then y from negative 3 to positive 3. So you involve, okay, the third, the fourth and the first quadrant. Okay, we'll take the theta exactly. So remember, for the fourth and the first quadrant, your theta is negative pi over 2 until positive pi over 2. Okay, and if I change a little bit, you see, I mean, if y here, I put it to 0, then we're left only first quadrant. If y, limit of y, okay, from limit of x, tell you two quadrant, fourth and first. If limit of y, I change y from 0 to 3. So we're left only first quadrant. So in this case, your theta is 0 up to pi over 2. So, okay, which, okay, dx dy or dy dx, okay, will affect, okay, your, the theta. So I hope you understand this one. You can look back, the notes of the cylindrical coordinate from your from the author. And then now we're going to solve this one. So now we can convert it. Okay, x you change to r cos theta, y is r sin theta, z maintain as z, dz maintain, dx dy become r dr d theta. This is called cylindrical coordinate. Don't say polar coordinate. Polar coordinate is in 2 dimensions. When it involves 3 dimensions, well, we maintain the z here. So this is actually the cylindrical coordinate. Okay, the cylindrical coordinate, not necessarily you maintain the z. I can maintain the x. If your solid is parallel with x-axis, so I maintain the x variable, then I change dz dy to r theta. You have to change it accordingly. If we maintain the x, later on it's not x is r cos theta, but the y is r cos theta, z is r sin theta. So you'll be more confused. That's why we just give you one orientation only. where we keep the solid is parallel with the z-axis. Okay. After that, limit of z, we can directly convert x squared plus y squared equal to r squared. Square root, okay, square root x squared plus y squared will get back r. And then limit of r, okay, limit of r is actually from here. From the limit of x just now, from limit of x from the upper limit of x equal square root 1 minus y squared, you square both hand side, we get x squared plus y squared equal to 1, which tell you r, this is what? R from 0 up to 1. So r from 0 up to 1. So theta from negative pi over 2 to positive pi over 2. Remember, okay, fourth and first quadrant, theta is from negative pi over 2 to positive pi over 2. The first quadrant only, theta 0 to pi over 2. First and second, 0 to pi. 1, 2, 3, 4 quadrant, 0 to 2 pi. So is it okay? So you just keep, remember the fourth and first, negative pi over 2 to positive pi over 2. Then you just evaluate it. Okay. Or you evaluate total you have r squared. So better you simplify. Take it first. R squared r times r cube cos theta sin theta. Okay, we got z, dz, dr, theta. Integrate respect to z, r and theta are constant. So all this constant. Then you just integrate z, you have z squared over 2. Then you factor out the cos theta, sin theta, dr, dr theta. Limit of r from, limit for z is actually from r squared until r. And we factor out the half. We're going to factor out the half. Half here I factor out. So it's 3 squared, which is sorry, not 3 squared, r cube. R cube. So mean total will be r power 6 minus r power 4 cos theta sin theta. And then dr theta. So integrate respect to r, lastly integrate respect to theta. So now integrate respect to r where the theta is constant. So integrate r power 6, you have r power 7 divided by 7 minus r power 5 divided by 5. Okay, limit of r from 0 to 1. Okay, and you have the cos theta sin theta d theta. So plug in the upper limit and the lower limit. 1 over 7 minus 1 over 5 cos theta sin theta d theta. Any mistake here? Yeah? Yeah. This r squared. Oh, on limit. Oh, just look here. So this is okay. That's too close. Go back again. After here, r cube cos theta sin theta r theta. Okay, limit of sec r squared until r. So I misput this one. Okay, so this is r power 4. R power r squared r squared minus r power 4. Okay, you plug in this one. I factor half already. So r squared minus r squared again r power 4. Then integrate respect to r. That's why this one is wrong. R squared. So you have r power 3 divided by outside still here. And pop it down. Here, you still got the r cube cos theta sin theta. So total is r power 5. This one when you expand here, total r squared times r cube, you have r power 5. That's why r power 6. R power 6 divided by 6. So r power 7 times r power 3, r power 7. Okay, so you have r power 8 divided by 8. That's here. Then expand this one. So expand in. So r power 5. Integrate it, r power 6 divided by 6, this r power 7, r power 8 divided by 8. And then, so this is 1 over 6, this is 1 over 8. Negative pi over 2, positive pi over 2. So this will be 8 minus 6 divided by 48. Okay, cos theta sin theta, you can change it to sin 2 theta. It's a 2 sin theta cos theta. So you can change it to sin 2 theta over 2. It's your sin theta cos theta. So cos theta, sin theta, we change it to sin 2 theta divided by 2 theta. So this one, half 1 over 4, and then this 8 minus 6, we have 2 over 8. Lastly, integrate from negative pi over 2 to positive pi over 2, sin 2 theta to theta, then over 2 over 2, 1 over 4, this one, and then simplify here. Over 96, negative pi over 2 to positive pi over 2, sin 2 theta to theta. Okay. Integrate sin is negative cos 2 theta divided by 2. We plug in the theta from negative pi over 2 until positive pi over 2. So the 2 here is factored out. And factor out negative also, and factor out 2. 2 times 96. Okay, so negative 1 over 192. Then substitute cos 2 times theta. Okay, theta is pi over 2. So minus cos 2 times negative pi over 2. This is cos pi, cos negative theta equal to cos positive theta. So this one is cos pi. So cos pi minus cos pi, that's why answer there 0. So that's why the answer is this one 0. Or from the last integral here, you can just use your calculator straight away. Then you no need to do manual calculations here. So, okay, any question? Okay, for question 2 here, the conversion equation from Cartesian coordinate to cylindrical coordinate. You can try the question number 3. Click 3, 4 also conversions, conversion equations. So I think you can try yourself number 3 and number 4 because it's similar pattern. Yeah, question 3, when you directly convert, limit of z is r squared until 4. And then from limit of y, okay, limit of y and limit of x, okay, can you tell me what is your region R actually? What is similar pattern to question 2? From limit of y and limit of x, can you tell me what is our region R there? Yes, 0 to 2 theta.
0 to 5.
Yes, so it is a circle centered at origin with radius 2 units. Then question 4, about question 4. Theta. X 0 to 2. So theta is this one. The question 3, your region R full circle. Question 4, which part? 3 and 4 or only 1? 4 and 1 or only first? Yeah, so this is theta 0 until theta pi over 2. Yeah, because limit of y tell you actually we got first and second quadrant. Because from limit of y 0 from y-axis, from this one, limit of y tell you the region R should be first and second quadrant. Limit of x, because x from 0 to 2. Okay, so it's only first quadrant. So first quadrant theta 0 to pi over 2. So this one is a fourth and first quadrant theta negative pi over 2 positive pi over 2. Full circle involve all four quadrants theta 0 to 2 pi. So it's similar. 2, 3, 4 is similar type. So I hope you can do 3 and 4 by yourself. Then you can move to question 5. Consider an object which is bounded above by the inverted paraboloid. Just now paraboloid, if z equal x squared plus y squared, your paraboloid is opened up, which consists K minimum point. Now it's negative x squared, negative y squared. So mean you invert the z now become negative. That's why your parabola is invert to mean or open down. With a maximum point initially is at 0, but z is moved up 16. That's why the maximum point shifted up to z equal 16. Initially, if you have z equal x squared plus y squared. The paraboloid open up. Okay. If z equal negative x squared negative y squared. So z become negative. That's why your paraboloid is open down. That is the maximum point at z equals 0. Now z add up 16. That's why the maximum point shifted up 16 unit up vertically. So this one is 16 here. This is a z. This is a f. This is a y. So this is a inverted paraboloid z equal 16 minus x squared minus y squared. So mean your upper surface is a paraboloid below by the xy plane, so means the bottom surface is on the xy plane or z equal 0. Okay, and then suppose that the density of the project is given by delta xyz equal to x plus x plus y. Find the mass of the object by using cylindrical coordinates. The density is given. We want to find the mass. Okay, mass of the solid is given by triple integral your density function delta x y z dv over the solid G. Your solid G is a paraboloid 16 minus x squared minus y squared bounded by the xy plane. So which is, okay, the paraboloid here is actually the solid is parallel with the z axis. Then we'll, okay, integrate respect to z first. And then this one, you see that this one, you can become z equals 16. You factor out your negative, so you have x squared plus y squared. So 16 minus r squared. So when you have the term x squared plus y squared, or you have the surface of paraboloid, cone, sphere or hemisphere, we can use cylindrical coordinate to be easier. We use cylindrical coordinate compared to use Cartesian coordinate. Okay. So that's why here we are going to use cylindrical coordinate. So what's the delta x, y, z? The density function delta x, y, z is 8 plus x plus y. So 8 plus x plus y. Okay, dv, I'm going to use dz. Okay, r, dr, d theta. Because the paraboloid, okay, x squared plus y squared can change to r squared. Okay, and so integrate respect to z first. So lower surface is on xy plane, which is z0. Upper surface is a paraboloid 16 minus r squared. So it's the limit of z is from z equals 0 until z equals 16 minus r squared. And then to get limit of r and theta, you need to project this paraboloid on xy plane. Happen when z equals 0. So when z is 0, 0 equal to 16 minus r squared. So r squared equal to 16 means r equal to 4. That's why limit of r is from 0 to 4. And they didn't say in the first octant, right? See the good first octant. Okay. They didn't say the first octant, so mean the theta is actually full circle. Theta from 0 to 2 pi. If sometimes if they say, okay, in the first octant only, so mean now you have actually total in 3D space, we have in 2D we got first 4 portions. What we said, quadrant 1, 2, 3, 4. 3, 4. And then because z in 3D we got z positive, negative. So upper part, when z positive got 4 portions, okay, z negative another 4 portions, so total is 8 portions. So first octant is a portion x positive, y positive, z positive. So if the question said this is in the first octant, hence your circle is actually in the first quadrant only. So the theta will be 0 to pi over 2. So however, in this case they didn't mention, so it's a full circle, theta from 0 to 2 pi. Okay, and then you can just integrate. Before you integrate, x have to change to r cos theta, y have to change to r sin theta. simplify. This is 0 to 4. 0 to 16 minus r squared. Okay. So x change to r cos theta, y change to r sin theta, okay, dz, and then you have r dr d theta. Okay. So better you expand in first, otherwise you forgot about this r. So 0 to 16 minus r squared. So total you have 8r plus, okay, I can factor out r squared cos theta plus sin theta dz dr d theta. So this is r squared, okay, r times r squared, r times r squared. So I factor out r squared. So now you can integrate respect to z. So when you integrate respect to z, r and theta are constant. So that's what you have 8r plus r squared cos theta plus sin theta. Okay, this is constant. Because integrate respect to z, r and theta are constant. So integrate constant respect to z, you have constant time z. So where the limit of z is from 0 to 16 minus r squared. So left dr d theta. We plug in the limit of the z. So you have here 16 minus r squared. Okay, we plug in 0, you have 0. Then you have to expand in, integrate respect to r, lastly integrate respect to theta. So you slowly expand it, 8r times 16. 8r times 16, then you expand it slowly, one by one. So 1, 2, 8r. So minus 8r cubed. 8r times 16, 1 to 8r, 8r times negative r squared, so negative 8r cubed. Okay, later on, slowly. 1, 2. So r squared cos theta plus sin theta times 16. So I have plus 16 r squared cos theta plus sin theta minus r squared times r squared cos theta plus sin theta, so minus r power 4 cos theta plus sin theta, so dr d theta. Okay, now you can integrate respect to r, where the theta is constant. So integrate 1 to 8r, we have 1 to 8r squared divided by 2, so become 64r squared. R squared then divided by 2, so 64r squared. So this one become 2r power 4, because this one r power 4 divided by 4, so become negative 2r power 4. 16r squared. Okay, when integrate respect to r, cos theta plus sin theta are constant. So here you got 16r cubed over 3 cos theta plus sin theta This is minus r power 5 divided by 5 cos theta plus sin theta, limit of r from 0 to 4, and then lastly substitute the limit, and lastly integrate respect to theta. So plug in 4. So 4 squared 16. So now we're going to plug in 16 times 64 times 16. So 1024. Okay. And then 4 power 4 times 2. 4 power 4 times 2. So minus 512. Then we have here 16 times 4 power 3 divide 3. So we get 1024. 1024 divided by 3 cos theta plus sin theta, and then this is 4 power 5. 4 power 5 divided by 5. 1024 over 5. 1024 over 5 cos theta plus sin theta. So lastly, integrate respect to can simplify first these two. Plus these two can be simplified. 1024 divided 3 minus 1024 divided 5. So we collect the second and the last term. So total you have 2048 divided 15 cos theta plus sin theta. Collect these two. Integrate 512 respect to theta is 512 theta. Then 2048 by 15. Integrate cos theta is sin theta. Integrate sin theta is negative cos theta. Limit from 0 to 5. We have 512 2 pi plus 2048 by 15 is sin 2 pi minus cos 2 pi. Okay, and then when you plug in 0, 512, this is 0. Sin 2 pi is 0, sin 0 is 0. Okay, plug in slowly for you to see. Sin 0 minus cos 0. With sin 2 pi, you get 0. This one, 0. Sin 0, 0. So you have here 1024 pi plus 2048 over 15. Cos 2 pi is 1, so it's negative 1 minus 2048 over 15. Cos 0 is 1, so minus 1. Then, so this is minus 1, this is positive 1, cancel. That's why the answer is 10245. The answer is 10245. Repeat one more time. This one is not that difficult. Okay. The mass is given by triple integral density function dV. And your solid G is bounded by the paraboloid Z equals 16 minus x squared minus y squared. Using cylindrical coordinate will become Z equals 16 minus r squared. So this is upper surface. And the paraboloid is actually bounded by xy plane, which is Z equals 0. So Z equals 0 is the lower limit. Z equals 16 minus r squared is the upper limit of your Z. And then to get we use a cylindrical coordinate. So the dy dx or dA change to r dr theta. So you need to know the limit of r. So to get the limit of r is actually to get the projections of region r is happen when z equals 0. So you let z0, you have r squared equals 16, r is 4. That's why the r is from 0 to 4. Okay, and they didn't say this solid is in the first octant, so you have a full circle of your projection. In your projection is actually your full circle from negative 4, positive 4, negative 4, positive 4. Which is r equal 4. Here is full circle involve quadrant 1, 2, 3, 4. That's why theta from 0 to 2 pi. Okay, later on, you just need to replace x by r cos theta, y by r sin theta. And after that, make sure, okay, for cylindrical coordinate or polar coordinate, don't forget you have a r outside here, r d theta. So r here is very important, you expand in first. If you don't expand in later on, you will forget. So total is 8r plus r squared, because factor out this r here, r and r squared. And then you integrate respect to z, r and theta are constant. So you get constant times z. Plug in the limit of z, so we got 16 minus r squared. And then expand it carefully before you integrate respect to r. So 8r times 16, got 1 to 8r. Negative r squared times 8r. So we got negative 8r cubed. They got r squared times 16, so 16r squared. Bracket cos theta plus sin theta. And then r squared times negative r squared negative r whole 4. Bracket cos theta plus sin theta. So integrate respect to r. And then plug in the limit of r. Simplify. Lastly, integrate respect to theta. Okay, plug in the limit of the theta. And you obtain the answer is 10245. So this is a question number 5. So do you have any question on question number 5 here? Now you can try to log in to your author. go to the assessment. Let's see whether you can see the quiz tool there.